So yeah, just to set expectations, this presentation is going to be pretty lighthearted. It's meant to be fun. We're gonna leave a lot of time at the end for questions, but I'm just gonna give you an overview of certain things to prompt those questions in your mind. Okay, this question, so this, what is this presentation about? Common mistakes people make with evals. And specifically, I want to give you a guide to wasting time, money, and resources. I learned this from Jason, taught me this technique. Eval is a really large kind of subject area. It can be dry. I don't want to just talk about, okay, best practices of evals, how to do them, so on and so forth. Let's make it fun. And so to make it fun, we can invert. And by inversion, we mean, okay, like how can we do evals wrong? I think that is a lot more fun. Let's get into it. I'm Hamel. Jason already introduced me. You can find my website there, as Jason mentioned. I've written a lot about evals. And the reason I've written a lot about evals is because this is where people tend to fail the most. And it's not really about evals strictly. Eval is just the how of making AI work properly. A lot of times people, when they're building AI applications, they hit a plateau because you're only doing, if you're just doing vibe checks, people want to know, okay, like how can you go beyond vibe checks? And evals is the central way for you to put some structured approaches in place that allow you to measure your application. Okay, what is the first step that you can use to really to start failing fast? And the first thing kind of mistake is focus on tools, not processes. I find that 95% of the folks that I work with, when we start working together, they have this mindset. And just like Jason, I do a lot of consulting. And so what does that mean? Okay, RAG problems. Instead of trying to measure retrieval metrics and things like that, use a vector database. You've already been beaten with that specific advice throughout this course, so you don't need me to really elaborate on that. Need to measure progress? Use off-the-shelf evals. So a lot of people are using off-the-shelf evals. We'll get into that in a little bit, but using off-the-shelf evals is the wrong choice 99.9% of the time. Fine-tuning without measuring, fine-tuning models. You don't even have to be using an open model, just like fine-tuning OpenAI, but without evals is a really bad idea. Similarly, if you have accuracy issues, okay, instead of trying to debug that and trying to figure out like why do you have performance or accuracy issues or the LM is not doing what you want, you're just trying like different models, just hopping from one model to the next. It just doesn't work. You're going to be spinning your wheels. Similarly, agents not working, try a new LLM framework. Okay, if agent's not working, instead of using LangGraph, try Llama Index. Llama Index doesn't work, try something else. And then lastly, probably one of the things that drives me crazy is like evals are a vendor problem. A lot of people think, hey, evals, what tools do I use? Should I be using Langsmith? Should I be using Braintrust? Should I be using Arise? What should I be using? That's the first question that comes to mind. That means you're in trouble because it's not a vendor problem, it's a process that you need to go through. And the vendor is not the solution. And so when you focus on tools, not processes, like what ends up happening is like your life is going to look like this whack-a-mole game. And this is my friend Greg. And you're really not going to be making progress. You're just going to be rotating around different tools without really having a robust way to improve things. And so just to drive this home, this is a real quote from a large Fortune 500 company. And the CTO said, in my opinion, the evals framework should be generic enough to apply it to any task. People actually believe this. And if you believe it, stop it. Get help. Get help somewhere. Get help from Jason, get help from John, doesn't matter. Get help from somewhere. So another kind of like example is if you really want to hurt yourself and really light stick of dynamite under your ass, you should throw up a dashboard that looks like this. Import your favorite LLM eval library and use off-the-shelf metrics. Calculate helpfulness score, truthfulness score, personalization, accuracy, tone. Put it on a dashboard. Be like, hey, I'm doing evals. And then you can tell all your coworkers, look how good we're doing. You can even track those metrics over time. But really, what are you doing good at? Nobody knows. You just have numbers that don't really mean anything. Who the hell knows the difference between 4.2 and 4.7? Does tone, what the hell does tone mean? This is actually a real dashboard, okay? It's not a screenshot of the dashboard. I asked Claude to recreate the dashboard slightly from a real screenshot of a client, but this is actually what I saw. And yeah, this is one way to waste incredible time and money because you're going to chase these metrics that won't really mean anything. And there's a lot of eval tools will offer these. You can like import from evals, import helpfulness, and you can apply that on your traces. And it's honestly, it's a waste of time. Do not do this. Do error analysis and find problems that you actually have and then measure those. Don't measure this generic bullshit. So let's go into it further. Just to drive home the point more, yes, to really maximize the blast radius of that dynamite under your ass, just let others dictate your metrics. Use all of them blindly and trust that they align with your goals. So, okay, like these are some examples. I think this on the left-hand side, this is like some eval tool inside OpenAI's dashboard. Oh, sorry. And they have some metrics here like sentiment, they have factuality, whatever. This is a screenshot from another eval tool, Brain Trust. This is one from Galileo. It doesn't really matter. If you really want to yourself fail as fast as possible, just adopt all of these at the same time, actually, and just like import all the metrics and throw it on a dashboard because that will cause maximum confusion. Okay, so that's like the first step to failure. The second step, if you really want to twist it further and really just maximize pain, is like just avoid looking at data. And these are some rules of thumb, some kind of beliefs that you can adopt to really be effective at maximizing this kind of failure. So one is just believe that a tool will do it for you. Like you don't need to look at data. This is the age of LLMs. Why should you be doing any manual work at all whatsoever? Just use a tool, just outsource it to the tool. It's not your problem, okay? And then also, okay, fine, if you do need to look at data, you know what? It's not your problem. Just let an engineer do it. All this LLM shit is just engineering bullshit anyways. Just let an engineer fucking look at your data. You don't need to look at it. And then also, just don't even look at data at all because honestly, just trust your gut. You don't need to look at anything. Your feelings are right, always right. And then ultimately, and a lot of people do this, is just depend on users to tell you if it's broken. So avoid looking at data. And just to drive home the point of delegating, looking at data to engineers, a lot of people do that. When we say, look at data, it's the person with the domain expertise that needs to look at data. And it's a critical mistake people make. So there's a technique called error analysis that you may have heard about in this course, or you may have seen indirectly, which is it's really important for you to go through your data and look at it and annotate that data so that you can discover the failure modes you have and to actually measure things that matter and not that dashboard full of XYZ metrics. Yeah, and we talk about it, I have a little page here. This is from a different presentation for executives, but if you want to maximize failure, don't do this. Do not look at your data, do not label it. And a lot of people, if you really want to fail even harder, just have an excuse that like, hey, looking at data is hard. You need to buy specialized tools to do that. Don't use simple, easy to use things. So being unsarcastic for a moment, you can use things like Excel to start looking at data and do this error analysis. I'm not going deep into error analysis now. We can talk about that in the Q&A. This is just more to bring up the point of, hey, like error analysis 101 is basically looking at your traces and categorizing the errors that you have and writing notes about them, and then doing some data analysis over those notes to highlight what kinds of failures you have. This is like an example, just a screenshot from some error analysis that I've done recently where, okay, like LLM responses, there's a lot of incomplete responses where the input had code in it. So that might not mean anything to you, but this is an example, and that drives, okay, what kinds of tests you write, what kinds of evals you might write, so on and so forth. And then finally, encourage agent astronauts. So instead of actually building anything, just keep drawing these diagrams. And I see this all the time. Oh, should we use LangGraph? Should we use, Llama Index? Is our architecture, like really sweat about if your architecture is right, if you're using like enough agents and what agent should go where, and just get really caught up in that. And forget about evals. Just start with the most complex solution. And then really the last thing you could do is really just throw away everything that has been the wisdom of classic machine learning. So this is a diagram. You may have seen it before if you're familiar with machine learning. This is from a Google paper about technical debt in machine learning systems. Where it's like machine learning systems are all very complicated. There's a lot of different concerns that you have: feature extraction, serving infrastructure, process management tools, machine learning code. And hey, we don't need any, you don't really, you can have the belief like, hey, you don't need any data literacy. You don't really need any of this knowledge because LLMs are just APIs. But really, is that really the case? And if you look really closely, a lot of these things are the same. Configuration, there's elements of that with when we talk about managing prompts. Data collection, you have human in the loop workflows when we want to curate data sets. This course covered RAG, so don't need to go into what that is. But there's a reason eval is at the center of this, because you want to verify what's coming in and out of the LLM. And then finally, on an unsarcastic note, you could also just ignore conventional wisdom. Hey, that manual inspection of data probably has, that is very important, and then evals are very important. But as you can, that's the sarcastic talk. Hopefully that was lighthearted and fun. We're doing a course on evals that will take you through in a lot of detail, like how to construct evals, how to deal with very complicated cases, like where you may have multi-turn conversations, where the outputs are ambiguous, what to do if you don't have data, what to do if you don't have users, all kinds of things. We go through that in a lot of detail. If that's interesting to you, check it out. Otherwise, we can have Q&A.
Awesome. Let me open up the Slide.io, and then I think there's only a couple of questions there, and then we can probably just have a conversation more about some of the things that you've seen so far in your consulting. The first question is, for the retriever component, what is the suggested approach for evaluating results when you have ground truth? Right, so this would be in generation, for example. Are you able to see the links, by the way?
Sorry, what was the question about links?
Are you able to see the questions as well? I just left a comment in the chat.
Oh, I see. Let me open it.
Perfect. You're still sharing your screen, by the way.
Let me stop. Okay, let me open the questions. For the retriever component, what's suggested approach for evaluating results when you have ground truth? So actually, you should look at Jason's blog. He has a really good blog post. I think it's like levels of RAG, maybe. And in that, let me see if I can find it.
I can take a look.
So there's like level 4 evaluations, and that's like a nice, very high level way to think about. In that blog post, it's called Levels and Complexity RAG Applications. He does like synthetically generate what the Q&A pairs are. The same holds true if you already have ground truth, if that makes sense. And you can
I think here this is also a good case of actually using something like an LLM to judge these results, right? Because, we have pretty good reasoning models now where given a certain answer, if it's slightly rephrased or anything like that, do you feel like just judging the similarity of a synthetic answer or a ground truth error with the LLM output is a pretty good idea? Or do you feel like even then we need to start thinking about training our own LLM as a judge? For just for comparing string answers, for example.
Yeah, if you're comparing string answers, then no. But if you want some more nuanced analysis, like you're saying, that you want some kind of LLM as a judge, that's fine. I think that in practice, you need to do an analysis that lets you trust your LLM as a judge. And what that means is you need to do some human labeling where you measure the agreement of the judge with you. Because at the end of the day, the reason why most LLM judge fails is people don't trust them and they don't understand them. So it's key that you do that. And I think that kind of answers John's question as well.
Yeah, do you think that with these new reasoning models, there's more to trust, or do you still generally think that the case that it still doesn't really live up to expectations? Especially with the O3 like mini, for example.
So you do have to check it. Like I don't care how smart it is. Even if it was you, Jason, manually judging everything, I would still check it to trust it. And like you might check it less, like the stronger the model it is. But you still have to do that exercise of, okay, does it match the domain expert? There's really no escaping that. Because at the end of the day, you have to trust the judge. There's only one way to do that.
I see. This is a question that I tend to bring up as well, which is, what if we don't actually care about the values of these off-the-shelf evals, but just that as we monitor them over time, we want to look at situations when they change radically? Imagine a line just kind of plummets at some random date, at some random time.
Yeah. So what you can do is you can do statistical tests and things like that to see, and you can set up monitoring on that to see, okay, if points are going beyond certain thresholds. So that's certainly a valid exercise. There's actually some people building tools that focus on just that aspect. It's certainly valid. I would say make sure that your evals are not too hypothetical, like that you understand if what the value means to you. So it shouldn't be like going back to that dashboard where I have all these random metrics and you just want to know if one of them changes drastically. I find that if you don't understand your metric, then it's just adding a lot of noise. I would just caveat, don't make the exercise too academic.
I guess a follow-up question on the off-the-shelf evals is, do you not believe in any general purpose eval frameworks? Or is it the case that we feel like it's too early in the tech cycle and we don't really have a strong standard yet?
So I think on balance, general eval frameworks where you just point something at it and it just tells you whether what your problems are and if you're doing good or bad, generally don't work that well. They demo really well in like sales meetings, but they don't work. And that's because domains tend to be fairly specific and the problems, they tend not to align with the problems that you should actually care about and the failures that you are actually having. They might surface some problems, but it's a slippery slope. Like you don't want to just rely on those and think that you've solved your eval problem because it tends to be fairly low signal. Now, if we start getting close to AGI, then maybe you could say, like, the work that I'm doing or Jason is doing to look at data and figure out like what you should be measuring and how you should do that. Okay, that can be done by an AI, but at this point, it's not at that. Maybe you could pose a general question to an AI at some point where it might be able to do that, but it's hard to know that without looking at data first and coming up with specific metrics. And then also like you can measure an infinite set of things. So you can come up with an infinite set of metrics. And also there's lots of different components in AI applications. There's tool calls, there's RAG, there's agents, and you can measure each component and you can ground really fast in all of these things if you don't prioritize and have some focus. And that's why it's really important to do error analysis first, to focus yourself on what matters. So that's another reason why I just don't think general purpose eval frameworks are a good idea.
Do you have any, okay, if the next question is, do you have any case studies or examples where you have defined some kind of very highly specific or highly valuable set of evals that you've implemented and worked really well? I have
Yeah,
a couple
so
of
I
my
can,
own, but I'd love to hear yours first.
okay, yeah, I'll just give you some really dumb examples just to drive home the fact that it doesn't have to be rocket science. So for example, if you see like UUIDs being emitted into the user or in the AI response when it shouldn't be because it's in the system message or something, okay, that might happen. Or you might have formatting issues. You might have others dumb things that you can easily write assertions and tests for that you know shouldn't be happening, but you only find that because you're looking at your data. Another example is I'm working with an AI apartment leasing assistant, and one of its jobs is to help make appointments, but it's always getting dates wrong. There's like some ambiguity sometimes in the way that you might ask for an appointment about what date you're actually talking about, that a human that you might understand, but the AI is getting wrong. So yeah, you can test that. You can test, okay, you can have ground truth there and you can write tests. There's some examples I've talked about publicly. For example, like I've worked on a lot of code things. So like a natural language query assistant. Like there's a product called Honeycomb where you can type in natural language query and it generates a honeycomb query. So in that case, yeah, I have LM as a judge that really bakes in like a lot of failure modes that tend to happen that is correlated with a domain expert and they trust it. So those are some examples of like everything from really stupid right assertion to like LM as a judge.
Yeah, I'll add one that I talk about in next week's lecture just because it's been top of mind, which is I worked on a sales bot where after the call, we would basically try to reference as many existing articles in our marketing content to supplement the conversation that we had. So maybe during the phone call, we talked about this new feature. We want to make sure that in our email, we link to that feature or link to a blog post that mentions that feature. And when we first ran this, what we found was sometimes it would either make up a URL entirely or the URL would be from our domain, so maybe it's like jason.com, but then the slug was wrong. And our simple eval was effectively running a regular expression to find all the URLs, verifying that all the URLs came from our website, And then we would make a small post request to that URL to make sure that page was not a 404. This is a very simple arrest. Find a regular expression, ping every single URL, verify that it's on our domain, it's on a whitelist of domains, or it has a 200 status. And just by doing that, we went from a 1% to 3% hallucination rate to basically no errors in our URL generation. This might feel obvious, but even deep research right now, if you ask it for tables of URLs, sometimes we'll just create example.com slash whatever. And so even deep research right now will give you URLs that don't point to anything.
And that's a great example
of,
you can only become aware of that kind of error if you looked at your data and you've looked at some examples. If you just threw like a general eval framework on it, there's no way in hell that would be like tell you about this very specific thing. That's why they don't work.
Yeah, there's been examples like early on in development where someone had asked a question about a feature and it would just pull this feature from any arbitrary provider and say, we also have this feature, but there's probably some probability that it mentions the feature from a URL from a competitor, and that would look terrible. But these tests again are very simple. Like another very simple eval was for meeting summarization, where our eval was just the length of the summary divided by the length of the transcript. And we knew we wanted to be between 40 to 50%. We didn't want it to be 10%, but we didn't want it to be 90%. And again, you don't really need any sophisticated tools to build those things out. And those are the things that really matter, right?
Yeah, and if you use sophisticated tools, you're gonna torpedo yourself because you're just gonna waste time. Like you're never gonna get to that answer.
Exactly. So a ton of these simple things are pretty straightforward. I think the second question is really interesting because you've also written extensively around this, which is what is the equivalent of a unit test, a integration test, and an end-to-end test for AI applications? And how do you focus on each one?
Okay, I've written about that so much that yeah, let me see if I can figure out a different way to say it. You can test an infinite amount of things, okay? Like I said, you can test the RAG, you can test the retrieval separately, you can test if function calls are working, you can do an end-to-end, you could just test the final output, you could do all kinds of shit. You can use LM as a judge. What do you test? That's the question everyone has. And the answer to that question is doing the error analysis, looking at your data. I would almost say evals is not even as important as looking at your data. And when I say looking at your data, it's a structured way of looking at your data. And there's different levels of sophistication of looking at your data. But just to begin with, it's going through your traces and categorizing different errors and then doing some data analysis on that to figure out, okay, what is like the most pressing problem that I should solve? And then also in there, you will find, okay, these are some things I should measure. You can't measure you shouldn't try to just try to measure everything. Now, the question of what is the equivalent of unit integration end-to-end tests, I think that doesn't really matter. I think it's apparent, like you can measure different components, you can measure the entire system as a whole. Just does the output work? Like is the output given to the user, the final result, is it what they're looking for? But really, it should be driven by the error analysis.
Yeah, and in these examples with the meeting notes, it was very much just the case that our customers kept saying that feedback that the summary was too short relative to how long our 6-hour meeting was. And okay, now we'll define one eval to address that. And then someone else would say, you know what, the links keep breaking. Okay, great, now let's add one more eval. It's rarely the case, at least in science, to create these evals before we actually build out the product. I think a lot of computer scientists, at least if you think about what the CS homework looks like, it's very much let's enumerate all the failure modes and then write software that captures these failure modes. Whereas I think in practice, a lot of the time, you will tend to deploy something, get some testers, get that feedback, and then you capture the evals through that negative feedback. This is also a really great question because I also have a pretty high conviction answer these days, which is, what is the least painful way to do human data labeling? How do you convince enterprises to dedicate N percentage of time to verify answers, especially when domain experts are needed?
So it's really important to remove all friction from doing human labeling. And human labeling, let's generalize that term a little bit to looking at data. Okay, so what I mean by that is where your data lives, if it's living in some kind of application, whatever logging system that you're using, you shouldn't have to click 10 times on something to read trace. Also, a lot of domain specific situations call for rendering the trace in a very specific way. Let's say you have markdown in your trace. Let's say you have widgets that you're rendering in your chatbot, whatever. A lot of times, like you need to render that information so that you can read it. You don't want to read a big blob of stuff that's not human readable. Also, a lot of times, like there might be metadata that you need access to. There might be external systems that you need to, or you need like side by side to evaluate whether a trace is doing whether this to evaluate like an interaction being successful or not. A lot of times, so for the simple cases, it can be really effective to use Excel sometimes. It depends. If it's really long multi-turn conversations that don't fit in Excel and it's janky, then you can't really use it. Sometimes you can use these observability eval tools. They'll have annotation queues, but it's really important that you're able to page through them very fast without having to click on a bunch of stuff. And a lot of times I build my own. Like you can build something in Streamlit, Gradio, whatever, and it doesn't take that long to build. You just have some buttons and a place to put notes, but then you can render stuff in the way you want. You can render the chat in the way you want. You can put metadata on the page. You can render markdown. You can render the widgets, whatever the hell. You can put links on there that link like whatever you need. And that's often worth it. It takes away all the pain from annotating. And because it's the most important activity you can engage in with AI, it's really high return on investment. I would say you need to think about doing that. And we're not really talking about that much time. We'd say like dedicate, how do you convince enterprises to dedicate percent of time? You don't have to annotate every single trace that occurs. You can sample. There's ways to sample. Jason may have already talked about you can cluster your traces. You can explore these different clusters, things like that. And it's not about, yeah, the way convincing enterprises is you can't skip it. If you skip looking at data, then you might as well just stop. It's not going to work, essentially.
As a consultant, there's been times when I've just offered to give them money back. Right? It's like, if you're hiring me to make your AI better and you're not going to label any data, then it's not going to get any better. So here's the money back. Let me know if you're more serious about doing this kind of work. I'll also add one call out, or two call outs really. The first one is, especially in the world of having things like Lovable or Bolt or Sonnet and Cursor, building one-off data labeling tools has become very straightforward, especially if you just make your backend some kind of SQLite thing, right? I think some of these new AI tools, they can just connect to Supabase and now you have a backend in the cloud. The second thing also is the fact that there are different kinds of tasks you can ask someone to do. If you were to give me a task that says, given this text, summarize something for me, that would take the human a lot of effort and cognitive load, and it would be a very slow task. That might take 3 minutes per label. But humans, and just like models, are much better at choosing preferences or doing binary tasks. So not only is it about what task do you build, but how can you make a task that should just be a pass-fail, right? If you generate me 2 summaries, it's very easy for me to tell you which summary is the better one. Whereas if you give me a single summary, now I have to read this whole thing and figure what's going on. Same thing with reasoning steps. It's one thing to ask a human to reason. It's another to say, given an LLM reasoning, do you agree with it or not? And again, it's all about making these tasks very binary, where they should just be J to accept, K to reject, and you're on to the next label.
Yeah, I would go any further and say highly bias yourself towards binary scoring. Don't have 1 to 5 scores because it's very complicated to align on that, and they tend to go off the rails. When you're beginning, you need to simplify and use binary kind of judgments.
Matthew, do you want to jump on to first question?
Yeah, I have a question about how to like evals in the context of experiments. If you're making a change to an LLM system, it seems largely the way a lot of people do it is just eyeballing, right? As in not really attempting to measure statistical effect and just seeing if a number goes up. And I was curious, I know the answer is probably it depends, right, on what ultimately you're trying to do, like what you care about, like the sensitivity or like how precise you care about your results. But from your experience, like working with a lot of teams on this, just curious if you see like how much of this sort of statistical robustness do you see when running evals, or interpreting the results of evals?
There isn't, to be honest with you, in the wild, I haven't seen too much robustness. People trying to add error bars on their evals and things like that. People struggling with creating the evals to begin with that makes sense. And it's quite the journey for people, at least now. Especially if we don't have data expertise or data science background. If you have data science background, totally different situation, but that's the minority of the situations. And yeah, there aren't many people doing it. Yeah, like it is worth thinking about, especially like if your system is stable and you have like good baseline from which to begin with, and you have some idea of what you're looking for. But yeah, that's my observation.
The closest I've gotten to doing this kind of experimentation is just 2 things, like either one, bootstrap sampling, with replacement to compute some kind of error bars when you do these like bar charts, or two, thinking about doing these like kind of t-tests. That said, I think a lot of companies I join, they start with only maybe 30 to 40 evals, in which case like nothing's really going to work. A lot of the statistical signals is really going to come in once you have hundreds of evals to run against. And so the first step, unless you already have hundreds of evals, is basically just to create synthetic data, create more tests, sample from user production traffic, and then get to a place where you can use something like bootstrapping or t-test to compare results.
Awesome. Thank you both.
John?
I wanted to follow on from this conversation, but also the previous. Whenever you have humans labeling stuff, help me understand a little bit more concretely where does that data go? Like, where do you store it? How much of it goes into a business discussion? This is what we need to focus on versus concrete, a unit test or like more formal evals. When do you do the evals? Is it when you're merging a branch, or is it just periodic, or is there like a time-wise pipeline of setting up evals for companies?
Yeah. So, okay, with the labeling, where does it live? It could live anywhere. You want some kind of database, ideally, that you can put stuff into, group them by annotation run or something like that. Sometimes it's spreadsheets. It depends. I don't try to be too dogmatic about it because the most important thing is people do it. And then it ends up it should be used for decision making. So you're like, where does it come up in the business context? Okay, we are seeing that XYZ problem is occurring a lot. Let's go fix that. And then ABC problem is here. We don't really know how to fix it, but let's go ahead and at least write an eval for that right now, to try to at least start measuring it because we don't even know how to fix it. Those are the kinds of discussions that happen. And then like when do you run? So let's say you run evals. So like evals have a cost. So, there's like the spectrum is like free to like very expensive. Free is writing an assertion. There's like a string comparison. Somewhere in the middle is like maybe LLM as a judge, which is okay, you're calling it LLM. And then like and then there's like whatever, humans like labeling stuff. There's not really like a silver bullet answer, but for the free stuff, you can think of that as this. You can run those just as frequently as you run your unit tests in your code. Whatever you have in PyTest, you can put those in PyTest if you want. Doesn't matter. With the ones that are a little bit more expensive, you have to be a little thoughtful. Like how expensive is it? And you might want to run it a little bit more infrequently, depending on what it is. There's like slow tests, and some of these tests like take time. They might take like several minutes to run. And so what I have done with my clients is like we have different cadences for different tests and different things that will trigger those tests. It's not just on every commit, it's like on some other kind of event that will trigger those tests, if that makes sense. Yeah, you just have to figure out the cost benefit and slot it in, but there's a spectrum that you can think about.
And your customers, when they're dealing with even the unit test, they can still be very non-deterministic. That like the unit test in this domain is a weird beast compared to what we've always thought of as unit tests. How do your customers process a unit test that doesn't have a deterministic failure, but always this weird stochastic stuff?
Yeah, so in those cases, like we're logging things. So sometimes I have some customers that I have LLM invocations in their unit tests because they're so cheap. Like they're like, it's not a big deal, whatever, who cares? And for those cases, like those metrics are logged to a database. And then they're just looking at really high level. Is the number actually like, is there a noticeable deviation? And there's some more analysis that's automatically done. It's not just one metric. It's okay, these are different product areas and different scenarios, and where are the errors in each of those. And then we have a side by side that shows like the baseline versus that, and we're just looking to see, okay, is there a large deviation? You could do a statistical analysis on it. Like I said, a lot of my clients are not there yet. They're like just getting to that point where like putting the plumbing in place.
Ashkan, do you want to go for the last question before we wrap up?
Yeah, my question is following up on the question of the quick eval for meeting summary generation, that you basically do a split and see how much summary you captured. Wanted to know if you have any experiences on creating evals for content generation, something like legal contract that's given a prompt or given a query, you generate a contract and you want to evaluate if you've captured all the nuances or all the articles have been mentioned or any similar experience. Want to know what would be the approach
Yeah.
for that.
Can you explain what you mean by all the articles are mentioned? Because in this example, you could have a situation where, given some request ahead of time, what articles should have been mentioned. If we have a golden data set like that, then you can think about something like a precision and recall for your citations. So given this context and this request, I know I should have mentioned articles 4, 9, and 12. Is that at least being cited? And if it's cited, that's one level of those would be like the binary tests, right? Those are the tests that you can run forever. Afterwards, go on.
No, I was gonna add for an example of article. Let's say we are creating a contract generation and it is in regards to a project, and we have series of older projects or a data set. And then given that prompt, we want to generate that contract and then check, for example, if the termination clause is mentioned or is not.
So there would be another set of problems, right? Like we could, for example, consider this in a way that's much more structured. In which case, maybe what I'm asking the LLM to do is actually return a JSON object first, and then I'm going to format that into a legal document. And if we do that, then we can verify specific attributes, whether they're missing, how long are they. That's one level. The second level of things that we look at is basically building a suite of judges where really it's just going to be like a rubric where maybe there are just 6 different checks I want to verify. And as long as you make each one binary and you verify whether or not these binary classifications are aligned with your own preferences, you'll effectively get a rubric that still is something that's very high quality. So one could be, I want to evaluate the structure of the output because every contract has to have a termination date. And so this is something I care about. Maybe I have a rubric where there's much more subjective things. And then lastly, just checking whether or not the documents that I think this answer or this question should have cited are actually being cited. And that could be more of like a precision and recall. Am I referencing articles that don't need to be mentioned? That would be low recall. Did I forget to mention Article 17, B1? If that's the case, then I didn't have good recall. It's usually going to be a suite of these things. And really, I would go down and say, okay, turns out we do have an issue with making sure these dates are extracted correctly. Let's build an eval for that specifically. Oh, I'm noticing articles aren't being created. Let's go build a single eval for that. But again, it goes backwards from the errors into what the eval should be, rather than just saying we should have a suite of evals.
I see.
Do you have any other examples of what
Yeah,
those
that's
evals
an
could
important
look
thing
like?
to repeat again. We should repeat that 10 times. Go from the errors you actually have into the eval. Do not ever go think about, oh, let's think of some evals and let's like slap it on your data. Just don't ever do that.
Yeah, that makes sense. For the example that I'm working on now and challenge with is generating response to a RFP. And there is generally, I've employed a system that goes and captures all the requirement, creates a bunch of questions, and then uses those questions to formulate the template of the response. But sometimes there are some nuances that is hidden between paragraphs or something that is very vague language that will be missed, and it's a critical thing. And it is something that like only because I have the domain expertise I could go read and then figure it out. And I want to know what, or if you had a similar experience from a different domain and like,
Yeah, we've done this kind of work in financial due diligence, but here what we've mostly done is make sure the templating that we do is very static across multiple industries. And so it's not the case that I extract the questions and create a template. It's more that I already have an existing template. And so there is always a question of how long have the co-founders known each other for? That's a question that we're going to apply in every single situation. And because of that, we then can just build something where we have the field, it's auto-populated by an LLM, and when a human is reviewing the template, they can always press thumbs up or thumbs down to figure out that this is good quality or bad quality. And now what I do is I just go over my template and go, what are the areas of my template that's failing the most? And what kind of investments do I need to make that better? And now usually it becomes a thing where, oh, we are not counting the names of the companies correctly. Because in some use cases, Calvin Klein for Calvin Klein is actually different than Calvin Klein CK, right? Okay, now let's go build out some deduplication evals to make sure we can solve this problem specifically. But there, the idea is we templatize things, we add buttons to collect feedback, and then we review that feedback to figure out what we need to improve next.
Thank you.
No problem.
But also, you don't need to be it's just worth mentioning. You don't need to be like overzealous about evals. Measure things that you want to track. A lot of times you'll see an error. If you're doing error analysis properly, you'll see a lot of things that you should just go fix. Oh, this is happening. I know exactly how to fix that. And then just go fix it. You may not need to write an eval for it. You have to use some judgment. Okay, should I be tracking this or not?
Yeah, the goal really is to make a better product. The goal is not to have some kind of comprehensive suite of tests. Ashkan, did you have a follow-up? I just saw your hand was still raised. In which case, I think this is a good time to stop. We have 2 minutes left. Again, Hamel, thank you for this. I'm pretty excited to hear the longer talk. When is your talk, by the way? Do you know if it's on like the Friday or the Thursday?
I think it's on Thursday.
On Thursday. Cool. I'll make sure we can make that, and then I'm sure we'll see it on YouTube and everything else, and I'll share it with the group afterwards. Great.
All right, sounds good.
Thank you so much, Hamel. Everyone
you.
else, have a nice day.